So today I'm talking about benzene, which is a bit like cyclohexane. It's got structure so these although I've drawn two structures here, normally you either just get one like that or you get one like that. Okay, so it's either this one or this one, where the carbon, these double bonds alternate, okay, and this is the equilibrium sign there. It actually alternates between both. These benzene has 6 carbons and 6 hydrogens. Okay, so it's got the formula C6H6. This is actually called the resonance structure because we will explain clearer later. Okay, more simplified version of this, which you normally see in textbooks, is when you have it drawn like this, or in this case you assume all the hydrogens are already present, or you can draw it like this. Okay, that's a bit wonky, but you assume all hydrogens are present, and the reason for the circle is to basically just illustrate the fact that double bonds are alternating between positions. Okay, they're just constantly alternating, so this just symbolizes that. Okay, so in benzene, when you have a carbon-carbon, I should point out, yeah, we know that, sure you understand that when you have this structure, it's basically this. So you, okay, so it's 6 carbon molecule like that. Each of the carbon-carbon bonds is equal to 0.154 nanometers. And the carbon-carbon double bond is equal to, take that equal out, is equal to 0.134 nanometers. So double bonds are shorter than single bonds, okay? And the carbon triple bond is even shorter. But I don't have the data and that number to hand. So double bonds are always shorter than single bonds. Yeah. So you got next, I mentioned this was a resonance structure, okay? That comes from the fact that if you draw the way this works, sort of to show you, is if you draw carbon like this or benzene like this. So these are p orbitals, and basically the p orbitals get overlapped, okay? They overlap. Okay? I mentioned because of this you get the electrons become delocalized. In nat phi chemistry you learn that in metal structures electrons are delocalized. It's a similar kind of idea of delocalized electrons, although the structures are different. So in these overlapping p orbitals you get weak overlapping of adjacent sp2 orbitals. Okay, so these sp2 orbitals overlap. So this basically, the electrons are delocalized and sort of resonate basically around all the p orbitals on both sides of benzene, and this is why you get alternating double bonds. So benzene is carcinogenic, which means it causes cancer, and it's also flammable. Yeah, I'll just stick with this for the moment. It gets a bit more technical, but it's you get these on both sides of the structure, so you kind of get a donut kind of structure form where you get delocalized cloud of electron ring like a tube of donut on top and below, as well as the carbon ring in the middle. So you get the bonds are alternating, but it's sort of delocalized. Anyway, another way of writing benzene is what we call phenyl, when it's used as a group and it's attached to another molecule like an alkane. So if you draw an alkane, if you want to attach a benzene to it, you can write it as simply pH, which means this benzene ring. Okay, so it's a shorthand way of writing. If you're trying to write lots of complicated chemical structures, you can write more simplistically, simply pH. Okay. Sometimes people, if they're writing wanting to add a methyl group on, you might simply write Me, because it's quicker than writing CH3. People often just put Me. So that's another way of writing benzene phenyl. Okay, so yeah, that's benzene.